Welcome to my channel. Let us discuss an expression for potential due to electric dipole. Now, as we know, electric dipole consists of two equal and opposite charges separated by a small distance. Say, this is a charge, point charge minus q, here point charge plus q, this point is A, this point is B, and O is the center of the dipole. The dipole has length 2L, and the dipole is characterized by dipole moment, and dipole moment is defined as the product of charge and separation between the two charges. It is a vector quantity directed from negative charge to the positive charge. This is the direction of dipole moment. 2L vector is directed from point A to point B. Now, we shall find out an expression for potential at any point, say P, which has the coordinate r theta. It is rather polar coordinate. OP length is r, and this angle that the vector r or OP makes with dipole moment is theta. Now, how to find out? Now, we shall use adapt vector means for the finding out potential. Potential is a scalar quantity, you know. Now, join the point P with point A, join point P with point B. Now, the potential at point P due to the charge minus Q be V minus, which is equal to 1 by 4 pi epsilon 0 minus Q by AP, and potential at point P due to the positive charge plus Q is 1 by 4 pi epsilon 0 plus Q by BP. Now, let us use vector concept. Now, OA vector is minus L and OB vector is plus L because they are of opposite direction. Now, OP is a vector, it is R. As a result, we know OA vector plus AP vector equal to OP vector. OA displacement, AP displacement equal to OP displacement. As a result, AP is equal to OP is vector R. Now, minus OA, AP vector equal to OP vector minus OA vector, that is plus H. So, this vector is R vector plus L vector. So that R vector plus L vector plus minus L vector equal to vector A. Now, similarly, BP vector is R vector minus L vector. Now, this is BP vector, that is plus L vector plus R minus L vector is vector R. Now, in this problem, the length L, that is the dipole length 2L or L, is very small, insignificant in comparison to the distance R. Now, so AP in vector notation, vector equal to R plus vector R plus L vector. As a result, AP vector equal to R vector plus L vector. Now, AP equal to magnitude of AP is r plus L dot r vector plus L vector root under, that is to the power half. Now we shall take the dot product, that is r vector dot r vector is r square, r vector dot L vector is r dot L, L vector dot r vector is L dot r, L vector dot L vector is L square. So that r square, r dot L is same as L dot r, so 2 r dot L plus L square. Now taking r square common, we have 1 plus 2 r dot L by r square L square by r square. Since r is very large, the contribution to the potential term due to this factor L square by r square is very small and can be dropped. As a result, this is equal to r square 1 plus 2 r dot L vector r square. So this term is dropped. So r square into 1 plus 2 r dot L vector r square. Since we are taking the root under to find out the magnitude, root under to find the magnitude, then it is equal to r 1 plus 2 r dot L r square to the power half. As a result, I can write that B minus is minus Q by 4 pi epsilon 0, and in place of AB it is R, that is 1 by R 1 plus 2 R dot L by R square to the power half. So V minus equal to minus Q by 4 pi epsilon 0 R 1 plus 2 R dot L R square to the power minus half. Now this term again can be expanded binomially and retaining only the first term, first two terms, and dropping the higher powers of r square, that is dropping the terms with higher powers of r square, because as I have told that r is very large, the contribution to the potential by this term is negligibly small and can be dropped. So it is minus Q 4 pi epsilon 0 r 1 minus 1 by 2 r dot L r square. Now this is equal to minus Q by 4 pi epsilon 0 r 1 minus r dot L by r square. If we multiply minus throughout, this is minus 1 plus. This is equation 1. Now similarly, if you expand the expression for potential due to the positive charge plus Q, it is B plus Q by 4 pi epsilon 0 1 by BP means R vector minus L vector mod, that is dot R minus L dot to the power half, or Q by 4 pi epsilon 0 R square minus 2 R dot L plus L square, and taking R square common, and this is to the power half. Taking R common, we have Q by 4 pi epsilon 0 R, and dropping this term L square by R square, we have 1 minus R 2 R dot L by R square to the power minus half, and this is equal to Q by 4 pi epsilon 0 R 1 plus R dot L by R square, neglecting the higher powers of the terms involving R square. Now, this is equation 2. So, the total potential due to the dipole at point P is B plus B minus, so Q by 4 pi epsilon 0 R taking common, minus 1 plus R dot L by R square plus this term, that is plus 1 R dot L upon R square, plus 1 minus 1 cancels, so it is equal to Q 4 pi epsilon 0 R square taken common, RQ R dot L, this is 2 R dot L, 2 R dot L, or this can be written as potential at point P, V. The potential V at point P is 1 by 4 pi epsilon 0. Now, this is 2 RL, R vector dot L vector, RL cos theta. 2 R dot L means 2 RL cos theta by RQ. Now, this is here Q. Now, 1 by 4 pi epsilon 0 RQ cancels, we have R square, 2QL, that is P cos theta, P 2QL, this is dipole moment P, R get cancelled, it is R square, P cos theta by R square. So, again, the total potential is 1 by 4 pi epsilon 0, 2 R L cos theta, 2 Q L is P cos theta into R is cancelled, R square, so P cos theta R square. Now, this is the expression for potential, that is B as a function of R and theta is equal to 1 by 4 pi epsilon 0 P cos theta by R square. Now, for theta equal to 0 degree, that is along the axis, that is in this direction, at any point theta is equal to 0 here. Now 1 by 4 pi epsilon 0, cos 0 is 1, so P by R square. Now if theta is equal to, here theta is 0 degree, if theta equal to pi, then in this direction, then it is 1 by 4 pi epsilon 0 cos 1 it is -1, so minus P by R square. That is, at any point near the positive charge, the potential is positive because the contribution for positive charge is more. Similarly, the point near the negative charge, at a point near the negative charge, the potential is negative due to the dipole. And if theta is pi by 2, 90 degree, cos 90 0, and potential is 0. That is, if you consider the perpendicular bisector, if you consider perpendicular bisector of the length of the dipole, at any point you consider the potential is 0. So this is an equipotential line, and no work is done in transferring a charge along this line. If you consider a plane that is perpendicular bisector, then at all points on the plane the potential is 0, and that plane is equipotential surface, and the lines of force starting from positive charge will meet this surface perpendicularly and converge to negative charge. Now, also you can write that this potential expression B R theta equal to 1 by 4 pi epsilon 0 P vector dot R vector by mod R cube. So the potential at point P due to the dipole can be written as 1 upon 4 by epsilon 0 P dot R upon mod R cube, so that P R cos theta R cube R get cancelled, R square. So this shows that the potential due to dipole is inversely proportional to square of distance, and potential due to a monopole, a single charge, isolated charge, is inversely proportional to distance, whereas it is inversely proportional to square of distance. We can also trace the lines of force due to the dipole. Lines of force start from positive charge and converge on negative charge. Potential is a scalar quantity. I hope this discussion can help the students understand about the potential of dipole at any point in general in polar coordinates. Thank you.